sine, okay? This, to me, if I'm just looking at my formula sheet, this looks like, on my formula sheet, my double angle identity for sine, which looks like this, okay? That's simply because I see a 2 followed by a sine term and a cosine term all put together. So if I was doing this on a quiz or a test, I'd just be playing matching and saying, what does that look like? So according to this formula, anything that looks like the right-hand side, which is what we have, can be simplified using the left-hand side. Okay? Now, that doesn't mean that you couldn't do something with what we have right here, right? If, you know, this is a problem that I could have done on my own before I even had the identities. I could have said, well, 2 multiplied by, what's the sine of 45? Root 2 over 2. Cosine at 45 is what? Root 2 over 2. I can do this problem. It's not difficult to do without a formula to simplify it with. If I was multiplying this out, then this is like a 2 over 1. If I'm multiplying all my pieces together, what's it going to give me on top? 2 times 2 is going to give me 4. On bottom, 2 times 2 is going to give me 4, and that's going to give me 1. Okay, so I can do that without a formula. I can just plug in what I know. What if this wasn't 45 degrees and I didn't know that from my unit circle? Okay? Then I want to use the formula. So what we can do instead of this is we can say if we recognize that this looks like this, our formula says we can simplify that to the sine of 2 times the x value, which what is the x value from the original problem? 45. So that gives me basically the sine at what angle? 90, which we may or may not find easier. The sine at 90 is just what? 1. I can get the same answer either way. It's just a little bit easier one way or the other. It doesn't mean you're wrong if you use one or the other. Sometimes, though, like I said, if those aren't angles that we know, you may not be able to do that. Okay? So same type of thing for question 2. 2 is a good example of what I was just talking about. If I wanted to try to do this on my own, do I know anything about 25 degrees?
No.
Nope, that's not in my unit circle. So now I have to use a formula. So if I'm looking at this, and I'm looking at my double angle identities, this looks a lot like which cosine one? The bottom one. I have a cosine formula that says the cosine of 2x is equal to 1 minus 2 times the sine squared of x. Okay? So that's just from my formula sheet, the third one down for your cosine. What I have looks a lot like this, which means I can simplify it using the left-hand side. Okay? According to this, if this is my formula, what's my x value? 25. So if I simplify it, it simplifies to the cosine of 2 times 25, which is the cosine at 50. Now this one, do I know anything about the cosine of 50?
Nope.
No, but we consider that simpler, so we leave it there. Okay? 3 is kind of a giveaway. 3 looks a lot like which one? 3 looks like my tangent function. According to my formula, again, could I do this one without a formula? I know a lot about 150. That would be fine. I could figure that out, but it would take longer. Okay? Here's the one issue with this. If I look at this, what is the difference between this and my tangent formula? One says 4 out here and one says 2. Okay? That is different than my formula. You have to notice small things like that. What that means is I can basically factor out a number to make this look like my other formula. If I wanted to say 2 instead, what can I factor out? A 2. If I just factor out a 2, all that affects is the top. Okay? Now what's in there looks exactly like my formula. My tangent formula says that this whole parentheses here simplifies down to the tangent of 2 times the x value, which in this problem, my x value is what?
150.
150. So then I just keep that 2 value that I factored out front, and we're going to multiply it by our answer. So this is actually asking me for the tangent at what number?
300.
At 300. So I can go to my unit circular chart. I can find the tangent at 300. Okay, which would give me what? Someone go look at your chart. At 300, negative root 3. So 2 times negative root 3 just gives me negative 2 root 3 as my final answer. So if you can find something out of your unit circular chart, go ahead and do that and get an answer. The last one we'll do like this before we just do a little bit of solving with this is number 4. 4 is similar to 3 in that 4 looks a lot like which of my identities? Four kind of looks like which identity? The second cosine one. I have a cosine identity that says this. Okay, what's the difference between this and what we see here? There's a 6 and a 3 versus a 2 and a 1. All I have to do with mine to make it look right is factor out a what? 3. If I factor 3 out, that leaves me with 2 cosine squared minus 1, which according to my formulas, 2 cosine squared minus 1, this simplifies down to what? Cosine of 2x, which in this case we just have x's and not numbers, so can I actually solve that out? Nope, so then this is simplified down as far as it goes and we leave it there. Sometimes we will use these to make substitutions and factoring problems, which is what we're about to see. That's the main use for them. That's actually, well, no, that's actually easier than this for a lot of people. You'll be surprised. Okay, so if you flip over a page or two for me, we'll finish up with that.
Test? Are you going to tell us like what to do?
Oh, no.
I'm going to
All right.
not know.
The main use for your double angle identities is to solve. Okay? In a question like number 1, I'm trying to solve for the value of x, and according to this, I'm going to use radians. Okay? The issue with this is that this term is not considered a like term with this one, and why is that? The x is inside. I can do nothing about these. One of them has a 2x inside, one of them has a 1x inside. It's not like you can just take it and divide by 2. It doesn't work like that. It's inside the parentheses. You can't get rid of that. So here's the main reason we use our replacements. For cosine of 2x, I have 3 options. According to my formula sheet, cosine of 2x is equal to cosine squared minus sine squared. Cosine of 2x is equal to 2 cosine squared minus 1. And cosine of 2x is also equal to 1 minus 2 sine squared. Okay, this is just out of my formula sheet. I have 3 identities for my double angle there. Okay? There's a good one, and it is the second one. Okay? Why would I want to use that one? Because it makes everything in terms of plain old cosines. Okay? I don't bring in sines. I don't bring in other terms that I don't need. Okay? So this makes a pretty simple problem out of something that looks complicated or somewhat simple. All right, if I make that replacement there, this simply now turns into a normal factoring problem, which is similar to one of the ones we were doing at our review tables. Okay? Where would I go from here? I'd move my cosine to the left, and then I'd substitute a letter for my cosine, a u, a y, something, in order to factor. You don't have to substitute a letter if you can factor without it. A lot of you would go to 2y squared minus y minus 1. Quick review of factoring. If I was factoring using the box for this, I'd put 2y squared in the first one, negative 1 in the last. Multiply those. That gives me negative 2y squared. Factors of that add up to negative 1 in the middle. are -2 and +1. Then I would take out greatest common factors. So my greatest common factor in the top row would be 2y. In the bottom row would be +1. Top, or first column would be y. Second column, because of this -2, I take out a -1. And then what do I do with my factors? Set them equal to 0. So if I set y minus 1 equal to 0, I'm looking for where y is equal to 1. If I set 2y plus 1 equal to 0, I'm looking for where y is equal to -1/2. But this is where we don't stop there. Several of you made the mistake on your quiz of this was my answer.
Wrong.
Okay? You substituted a y for a what? Cosine. So we're looking for where is cosine equal to 1 and where is cosine equal to -1/2. So to get my answers for this in radians, I think about where is cosine equal to 1. That's my x value. That's going to be 0 and 2 pi. Where is cosine equal to -1/2? 2 pi over 3 and 4 pi over 3 from my unit circle. So a lot of that problem is very, very similar to stuff we've already done. The first step is different. You make a substitution anytime you have a 2x in a parentheses for that term. That's it. Okay? Let's try that again, only with question 2. Question 2 is one that you actually do not have to make a substitution for. You don't always have to do that. Okay? And so the reason I don't have to make a substitution there is because I only have one term, right? If I was solving this, okay, I'd be saying, okay, where is sine equal to what? 0. The only difference in this problem and this problem is the 2, right? So when I ask myself where is sine equal to 0 in my unit circle, that's solving for 2x. It's not actually solving for x, so it takes one extra step at the end here. Okay? So let's answer the question, where does sine equal 0 in our unit circle? 0 and pi and 2 pi. Okay? If that's solving for 2x and I want to solve for x, what's going to be my last step then? Divide by 2. Now here's the only tricky part of this. When I divide by 2, that essentially divides my unit circle in half. And it gives me only half of my possible answers between 0 and 2 pi. So because I know if I take all of these and divide by 2, that's going to give me what answers? 0, pi over 2, and pi. I only have answers from 0 through pi. I want answers from 0 through 2 pi. Okay? So when I know that I'm going to have to divide by 2, I do an extra step back up here. Okay? This is one rotation around the unit circle, right? Because I'm going to divide by 2, I want to go a second rotation around the unit circle by adding 2 pi to each of my answers. If I add 2 pi to 0, what do I get? 2 pi. I already have that one. If I add 2 pi to pi, what do I get? 3 pi. And if I add 2 pi to 2 pi, what do I get? 4 pi. Now if I divide all of my answers by 2, it gives me my full set of answers between 0 and 2 pi. So that gives me 2 more answers, which is what? 3 pi over 2 and 2 pi. Okay? If you have sine of 2x, you're going to want to go 2 rotations. If I have sine of 3x, I'm going to want to go 3 rotations. It's not really that difficult. You just have to remember to do it. Okay? Flip the page. We're going to practice again. Okay? We're going to practice another one like that because those kind of are a pain in the butt. Okay? This is 2 is the same problem. We're not going to do that one. We're going to finish out here with number 1, and we will be done. This is asking me the question, where is sine equal to 1/2 in my unit circle? So that's going to solve for 2x for me. I go to my unit circle and I ask myself, where is sine equal to positive a half? 2 places. Pi over 6 and 5 pi over 6. Because I know that I'm going to divide by 2, before I ever divide by 2, I say, here's my first rotation around the unit circle. How do I get my second? Add 2 pi to each of my answers. 2 pi in terms of sixths is what? 12 pi over 6. So that's what I'm adding to both of these. So if I add 12 pi over 6 to my first answer, I get 13 pi over 6. And then 17 pi over 6. To get my final answer, if I want to get x by itself, what do I have to do? Divide everything by 2, which really just takes the bottom of the fractions and multiplies by what? 2. So that gives me 4 answers. What are they? Pi over 12. 5 pi over 12. 13 pi over 12. Okay, and all of those are inside 2 pi. Yes. Okay? 17 pi over 12. Okay.